guys, welcome back. So what we're looking at today is 4.2, shift and stretch. So let's go ahead and jump right in. So we want to find the zeros of each polynomial. So remember, finding the zeros is where we set each part of the equation of the polynomial equal to 0. So for the first one, if we set each one of these equal to 0, we would end up with x equals -4, x equals +2, and x equals +7. Those would be our zeros for the polynomial. Now, in the case of these are a little different simply because we've got that squared. So remember, take the square root when you set it equal to 0. Now, this one right here, finding the zeros of this, if we subtract the 25 from both sides, we end up with x squared equals -25. We take the square root. Now, we have a negative under the square root. Remember, that can't happen except with imaginary numbers. So our solutions are 5i and -5i. Remember, anytime there's a negative under a square root, we can take and use the imaginary numbers to fix that. All right, find the domain of each of the rational functions. So remember, domain is possible x values. So if we look, our x values are all in the denominator. Also notice the equations from the first set, or the values from the first set, are the exact same in the second. So the domain for this one right here, well, 6 divided by 2 is 3, so all real except x equals 3. Sorry, -3. X equals 1/8. And x equals 5. So these are all the cases where if we plug in these values, 2 times -3 is, actually that should be a +3, not a -3. Sorry. 2 times 3 is 6. 6 minus 6 is 0. That would make the denominator 0. It would no longer exist. 1/8. If 8 times 1/8 is a +1, -1 is 0. 5 minus 5 is 0. So we're looking for what makes each of these values in our denominator 0, because those are the values for which it cannot exist. We can't have a 0 in the denominator. That does not work ever. You guys know that. All right, and for 7, so 9 times what? +3. 9 times a -1/3. So all real except x equals -1/3, because -1/3 times 9 is -3, plus 3 is 0. And then for the x squared one, if we square 3 or -3, we will get a +9, and then that will cancel out. So those are the values for which it does not work. So same idea for 5 and 8. And hint, these values are the same. It's finding the zeros. What makes it 0? Finding the zeros. Hint, hint. All right, the next section, identify the vertical asymptote, horizontal asymptote, domain range of each function, then sketch the graph on the grids provided. The grids for these are on the next page. So for number 9, our vertical asymptote, so that'd be where it can't cross vertically, is going to be 0. There's no shift to this, so it's just x equals 0. Our domain is going to be from -infinity to positive, or to 0, with the union. The U means union, so also from 0 to infinity. So it's showing that there's that asymptote at 0, so it can't be 0, but it can go in between, or to either side, I should say. And our horizontal asymptote is y equals 0, because there's nothing added or subtracted here. So like in this one, horizontal asymptote would be y equals 2. vertical is x equals 0. So if there's nothing with your x value, then it's just x equals 0 for your vertical, okay? And then our range here would be negative infinity to 0, union 0 to infinity. Here in this one, we would have negative infinity to 2, union 2 to infinity. And this would be our negative infinity to 0, union 0 to infinity. So just like so. So asymptote is your key word for this lesson, asymptote. Now, to graph this out, so we'd have a point here at 1, 4. We'd have another one at 2, 2. Oh, you can't see those points. Hang on. All right, so 4, 1, and 2, 2, and 4, 1. And then negative 4, 1, negative 2, negative 2, negative 1, 4. So this is just plugging in values of our function in. So just plugging in different x values to see what the y values are. So we've got this right here. And so we can see they're approaching the axes. Mine's not as close as it should be, but never crossing either of those axes. So in this one down here, notice we have the x minus 3. Here we have the x plus 5. So we have to be careful. Those are the ones where it's going to change our vertical asymptote. So this would be x equals 3. This would be x equals negative 5. This one would just be y equals 0. This one would be y equals negative 4. And so then use that to help you come up with domain and range, and then plot some points to show what these would look like. All right, for 13, write a function in the form f of x equals a over x minus h plus k, where the vertical asymptote is a negative 15 and a horizontal asymptote is negative 6. So use what you know from these up here about where the vertical and horizontal asymptotes are to help you write it with these specific ones, okay? All right, and last but not least, finding the roots and factors of a polynomial. So this is going back to our dividing the polynomial. So if we look at this one here, x equals negative 1, so that means one of our factors is x plus 1. So we would have x plus 1, we're dividing minus x squared minus 17x minus 15. We'd multiply by an x squared, so we'd have x to the third plus x squared. Subtract, they both cancel, or wait, nope, they don't both cancel. Oops. Negative x minus, or negative x squared minus x squared is a negative 2x squared minus 17x, so we multiply by a negative 2x. Gives us a negative 2x squared minus 2x. We subtract those cancel. Negative 17 minus negative 2, so really negative 17 plus 2 is going to give us a negative 15x minus 15. So we multiply by a negative 15. So we end up with negative 15x minus 15, which is 0. So we have x squared minus 2x minus 15. So the two things that multiply to give us a negative 15 and will add to give us a negative 2 are going to be a positive 3 and a negative 5. So our factors are x plus 1, x plus 3, and x minus 5. So our zeros, our roots, are negative 1, negative 3, and positive 5. So just like that, you are dividing these to take and reduce it down based on the given factor that you have, and then you'll be able to take and factor it like normal afterwards, okay? All right, if you guys have any questions, feel free to ask. Have a great day.